Alright, so my flipbook's done. You can see that this other window that pops up here is where it's at. If I go up here, click play, you can see we've got our particle sim. Now I can already tell, based off of this, that these particles are moving too fast to my liking for my final product. Now I like the motion of them, for sure. I just want it to be slower. So rather than going through DOPS and trying to reconfigure my drag settings and my, all my settings for the turbulence fields and stuff like that, and the attraction forces, rather than dial all those down, I think we can remedy this situation with a good old-fashioned retime. Actually, it's pretty newfangled. The retime node is pretty new. I think it came out in Houdini 17, but it's there's been other ways to retime in Houdini, but this new retime node is super handy. So I think that should be pretty cool. We can check that out. I'm seeing let's see if we can find an area in here that looks pretty cool. Kind of like this, where they're all kind of just doing their own thing and then it comes back together. Maybe we can pick a nice region that we like. You know, while I'm at this and observing this, I'm seeing that there's like a lot of buildup as these spheres are clinging to this surface of this object. So I want to see if, at this point, why settle, right? We have full control over just about anything we want. I think that maybe I would introduce a little bit of a repulsion force along these surfaces so we don't quite get just a complete static buildup of these. So let's see. I know that there's an option for a reversal distance on our node, on our attractor node. So I want to see if I can mess with that. So rather than deleting this entirely, if what we come up with doesn't end up looking better than this, I can always revert back. So I'm going to just save my file up. So if I go File, Save As, and I'm just going to increase this to version 2, like so. And then you'll notice that if I go back to my pop cache, it errors out because it's looking for $hip name, which we saved as version 2. So if I really want to get back to this cache, what I'll do is I'll middle mouse click on here and that shows me what hip name evaluates to. Well, I know I just want the previous version. So if I just copy this, go back to the version, hit the middle mouse button, and instead of hip name, I just select that and paste. So now we've just hard-coded the file name. I'm just going to delete the version 2 off the end and just change it back to version 1, and we get our old cache back. But because we're going to actually cache a new cache, I'm going to put this back to hip name. But that was just a demonstration about how you can sort of hard-code those things so that you can access other versions of your caches even though you're changing your file names. So let's just jump back into our .NET here. I'm going to, let's see. I'm going to hit escape because I'm in the middle of it. And I don't want to resim it without changing the settings first. So let's go in here to this pop attract. You can see here this pop attract under the force section, it's got this reversal distance. So if I just hover over here, you can see that it gives us this info. It says particles within this distance will experience a repulsive rather than attractive force. At exactly the reversal distance, the force is 0, growing it until it reaches an additional peak force distances. Okay, fine. So I'm going to just turn on my grid and kind of see if I can see like what a good size would be. So if we've got our, let's just play this. Let's play this down a little bit. If our, let's see. If I'm going to hit escape, if our sphere here, it looks like, I'm just going to hit spacebar 2 to go on the top view. It looks like this sphere's got a radius of, it looks like it's about, maybe 2-ish, 2.5, something like that. So I'm going to, let's just put in a reversal distance of 2 and see what that gets us. Does that get us any different type of behavior? Hitting spacebar 1 to go back into perspective view, and then I'll just select our camera that we had before. And I'm just going to play this down a little bit to see what happens if I add a reversal distance into that force. Are the particles still clinging to the surface of this object as much as it did before? Yeah, it's looking pretty interesting. I mean, there is some collision happening, of course, but it looks like it's actually, yeah, it's actually like getting pushed around a little bit more. Um, that seems kind of interesting. I almost want to just compare what this looks like to what our previous cache looks like. So at this point, so what I'm going to do is let's just cache up to frame, however we want, frame 200. So I'm just going to go over here to the export particles section, and I'm just going to right click on this end. It's set to, by default, cache 1,000 frames. I'm just going to delete this channel, and I'm just going to cache this out to 200 frames instead. And since that's already loaded in memory, it should go pretty fast. I'm just going to click save to disk. You can see here in our project directory, we've got our cache folder. In our pop cache, we should have two folders, one for our previous version, one for our current version. That's cool. And it's saving this stuff out to disk, and then I can just do a little quick comparison. It's still got queued right, so it actually, yeah, there we go. All right, so it's saved those out. What I'll do is just copy off this pop cache and do what I did before. So I'm just gonna middle mouse click, copy, middle mouse click the parameter again, and then select the $hip name, paste, and then hard code this back to version 1. So now we've got a, I should have a version 1 appearing here. What's going on? Not seeing it. Is it loading this guy? Oh, the reason why it's not loading is because it's looking for pop cache 1. And it's looking for pop cache, not pop cache 1. So there isn't a file created in our directory called pop cache 1. We're still looking on pop cache. So I'm going to have to hard code $OS as well, unfortunately. So I'll just type in pop_cache. And then I'm going to just copy this and copy, and I'll just paste it again over here where it says $OS. Just going to do that. And pop cache. So I've got those two now. If I select this, is it loading? No. Let's see what I might have screwed up here. Oh, I didn't. That's the other thing is if you middle mouse click on your geometry file and it's displaying the full string, when you go to edit it, it doesn't do anything. So you got to go middle mouse click it so that all these expressions are appearing and then go and hard code it. So little gotchas to keep in mind. So pop cache here. I'm going to copy that, go over to $OS here, and paste it, enter. So now we've got our old cache and our new cache. It's quite wildly different. So maybe I can, let's see. Let's just going to back my camera out a little bit and throw down a transform. And I'm going to grab this pop cache and move it off to the right. Oops. The right in this world would be -Z. So like so, and then I'll just merge them together. And this is not what I'm going to export or anything. It's just good for kind of viewing the variation between these two sims. So let's see. Play it down. Yeah, as we get over here, this collider, you can see that repulsive force is actually creating sort of like a little an edge where it's almost like it's almost pushing off a little bit more. I'm gonna just move this guy over a little bit more and maybe back off just a little bit. All in all, I'm liking how this one's a little bit more chaotic. I think I might just split the difference. Yeah, I might just do. I think I'm just gonna have it. So instead of a reversal distance of 2, I don't know if is it a reversal distance. See, this is the thing, is if it's a distance, then if I change that and decrease it, it probably won't change the force. It might actually make it so the distance. Either way, I'm gonna just try it out. So we're just gonna try this reversal distance and see if it actually gives us something different. So let's just cache this out again to 200. And we're back. All right, so now let's compare what we've got between these two. They're pretty close to one another right now, but they're still different enough. Like if I look at this left if I look at this go, I'm gonna hit spacebar B. Oh no, not spacebar. Let's see. If I go back, I'm gonna scroll back here to I'm gonna hit spacebar 1, and then I think it's Control B to make this view bigger. So I'm just going to kind of play these both back and just kind of scrub the timeline a little bit. See how this sphere, this collider that's obviously right here, and then there's this one right here. It looks like this one's actually got just a little bit more push off occurring on that side. And then, yeah, one thing over here, we get this nice kind of curl, but that isn't really happening on this sim right on this side. Not quite sure why, but there's a little suggestion of it right here. I'm just generally liking how this one on the left just has, it's hard to say. I mean, this does have a lot of really cool, a lot of really interesting things to it, but this one just feels like it's got a little bit more breathing room. I can't quite put my finger on it. I think it might be a reversal distance. Yeah, I'm liking it. So I'm gonna just cache this one out here. It's got this floaty, this more spatial thing going on with it. And I like that we're not getting so much buildup. And if we are getting buildup, it's less. It's sort of being repelled away. And I just want to go with it. So you can do whatever you want. So we're going to do that, I think. I'm going to hit Control B to go back to my old view. And I'm going to just go over to my pop cache here. And I've got it cached out to 200 frames already. So what I'll do is I'll just change this end. I'll just revert it back to the default, which is end. So it's going to go out to 1,000. And instead of recaching the first 200 frames, I'll just pick it up where we left off. So I'm just going to delete this channel temporarily and put this to 201. Hit save to disk. Let this guy cache out, and I will be back in a sec. All right, so that cache is done. Let's review. We've got our particles doing their little thing here. Yeah, that's very fun. Let's go in here to camera 1 and just kind of I'm going to kick off a flipbook real quick so we can watch this in real time. I think I can see some moments in here that I'm really enjoying already. And let's see what we got. I'll just click this flipbook button and it's going to pop this guy open over. Where is it? Here we go. And I'll be back in just a moment. So I stopped the flipbook because it looks like where I reset my cache to manually go from frame 201, there's a little pop here. And while I'm actually fully okay with using either end of this, I think that just to make sure that everything is going smoothly. See, I must have missed a setting, but I feel like this should have been seamless right here. And just because I want to be able to be 100% sure that I can fully reproduce whatever is going on based off of the settings I save in my file, I'm going to recache this. So I'm going to just pause the video real quick and do that one more time. So again, that process, just going to close this down, go over to pop cache. I'm going to revert this to defaults. So it's going to recache the full frame range. So hopefully we'll get rid of that pop here. So I'm just going to click save to disk and I'll be back in a second. All right, so I've re-simmed and re-flipbooked or recached and re-flipbooked my simulation here. So this is sort of the motion that I got. I'm liking it. I'm going to go with it. And I think at this point, what we can do is do a little bit of post-processing to get this thing into shape. One of the things I want to try to do is I want to create a seamless loop out of this, and I want to find a region of the simulation that I like, and then loop that. And the other thing I want to do is just get this thing ready for cinema and kind of clean things up a little bit in that regard. I think I also want to slow it down a little bit. So, all right, so let's just look for an area that we like. I like that part. I kind of like how it comes together like this, and then it gets ripped apart. this swoop right here is really nice, like that. So maybe like that's good. I also really kind of like how in this region over here, this sphere on the right comes up and then kind of changes directions and then starts pushing all these particles away right here. So maybe we could use an area that is between maybe frame 210 and then give it a little bit of handle after this sphere comes down. So maybe like at this point where it's coming together, we'll bring it to maybe from 210 to frame 600. So I want to focus on that region first. So I'm going to just minimize this. Let's go into our export particles. You can see we've got our cache here. I don't need this other pop cache reference thing anymore, so I'm just going to delete that. So one of the ways that I can isolate regions of my animation is by using a time shift. So a time shift basically will give you, not the time blend, I want the time shift, like so. The time shift basically gives you it has an expression for which frame you're on. You can just, I could delete this and manually choose any frame of our simulation that I want. So I think that if we're going to retime this, we actually want to jump out and have frame 600 actually equate to be frame 210, which is, you know, back here. So the way we get this to do that is we can just simply math it out. I don't want to think about it. Just put in $F. And what do we need to subtract from $F? Well, we need to subtract the difference between whatever frame we're on, just 600 minus 210. So I'm just going to hard code that in here, saying $F minus 600, and then in parentheses, I'm going to put minus 600 minus 210. So that should immediately evaluate backwards. And then I'm going to actually put a clamp to both on here, which basically means that when I'm subtracting frames, if I go back below into the negatives, it just clamps to that first frame. If I turn this off, I get an error and things, it just doesn't work. So I'm just going to clamp this to frame 210, or sorry, frame 0 at the earliest, and then it's going to be basically, we've just offset this whole thing by however many frames this is. I can't do math in my head. I think it's maybe like 490, 390, something like that. Yeah, 390. So now we just need to do a blend shape with the original. So I'm going to throw it on a blend shape. Blend shapes. And we're going to grab this original one. This is our first input, is going to be the actual animation. And then we can start our fade maybe around frame 480. Yeah, we'll go from 480 to 600 is when we'll do our blend. So I'm just going to hand key that in. So at frame 480, we're going to set a key. We're going to set a key on our blend, 481, whatever. And then let's go to frame 600 and then change our blend all the way up to a value of 1. So between these two values, you can see it's just blend shaping back to that earlier that offset time shift that we put over here. So now if I bound this from 210 at the beginning of our time range and 600 at the end, and I play this back, I'm going to just hide the collider because it's not going to be synced up right yet. So I'm just going to hide other objects, and let's just play back the end of this and see if it seamlessly loops. So we're getting there, we're getting there, we're getting there. We're getting towards 589, 89, 90, 96, 97, and it shifts back. That's because our camera isn't set up yet. So I'm just going to pop out of the camera by just moving, since I don't have that lock selected. So now we're here, we're at frame 210, goes through all these motions. Then we get out here to frame 590, and it's going, and boom, it seamlessly loops. So yeah, as we go through here, it kind of goes through that shifting phase in this last several hundred frames, like so, last 100 frames or so, and then we're back to where we were. So now I want to get this to also work with the with our colliders, so we could potentially have them exported as part of our animation as well. So over here, I'm going to navigate over to our collider. I'm going to go to the, let's see, I'm going to go to, let's grab the collider geo. I'm just going to copy these nodes and just paste them over here. And now if I wire in our collider geo and our blend shapes, and these are wired backwards, so I'm just going to hit Shift R to reverse them, Shift R again to reverse them. Something weird was going on, but hitting that a couple times fixed it. If it isn't fix it, you can just disconnect and rewire them, or mess around with this little box down here. We'll switch them for you. So now, as our animation plays through, these are our colliders. Our colliders are going through, and they blend shape back to the beginning as well. Let's see, let's play that down, and it comes back, and then it loops back to the beginning, and that's seamless. Cool. I think I'm going to just decrease the time shift, or the amount of time that we're blending for, just to make that a little bit quicker. So I'm going to actually, so I don't have to key this in two places, I'm going to copy the parameter here. I'm going to go over here. I'm going to say delete channels, and then I'm going to paste relative references. So I only have to animate the looping on the pop cache for it to affect the blend shapes on the collider. So now when I'm over here, I can grab my key and just drag it out. I'm just middle mouse grabbing that key, and maybe I'll drag it to something like, 528. See how that looks. So I'm just going to play that back. Let's just, for the sake of seeing everything all at once, say show all objects, and I'm just going to play back the end of this to see how that loop looks. So it's coming back, kind of does its own little explosion thingy. Now there will be some sort of intersection at this point for sure, as it's making its way to its next shape, but then it should loop through seamlessly like so. So yeah, it does get a little bit messy, but chances are people aren't going to notice that too much. Totally up to you. I might actually bring this back out to 500 or something like that. Just kind of trying to time the most chaotic portion of this blend to be when these shapes actually come together in the middle. So if I go over here to my collider geo and I just hide other objects, you can see that right around 540 is when this when these spheres cross 0. So if I actually try to make it so that 540 is the middle of my blend, it'll kind of hide the fact that it isn't a perfect collision in the middle there. So what is this? That's 540 that's 60, so about 120 frames. I had it right at about 480. I'm just going to put that back. Now I've got the seamless loop, and what I want to do is just slow down this simulation. It's just a little bit fast for my liking, so I'm going to use the retime node. So let's throw it on retime here, and I'm going to work the retime onto our particles, and then we'll also just copy this over to our colliders as well in a second. So I'm just going to put this in here. And you get an input range from 1 to 100. We actually want an input range of 1 to 1000, like so. And if I, by default, it's doing nothing because it's set to speed mode. Now you have all these different modes you can do by frame, by time. You can shift range, fit range, all that stuff. I want to just slow this down to, let's say, a quarter speed. So I'm just going to put down 0.25. And now all of our particles are moving super slow and dreamy but our colliders aren't. So let's just copy this retime and paste it right here. And now our colliders should also match up, and it looks like they do. Cool. So now what this has done is it's shifted everything to be a much longer timeline. So now we're 4 times as long. So I'm just going to change this range to be 4000. So now our 1000 frame cache goes all the way out to 4000, but we're really only concerned with the portion that we looped. And we looped from frame 210 to frame 600. So let's just let's just figure out where we're at here. So I'm just going to do 210. I could probably do this in my head times 4, but just to be sure, we know how that turned out last time. So our loop is going to start at frame 840 now. And it's going to end at what would be 2400. So right around here should loop. Let's go. I'll just set the end of our range to 2400 because I can do 600 times 4 in my head. So if I play this back now, this should loop back to 1 in just a few frames. And there we go. So that's looking like that's looping well. One thing I want to do is the retime is set to use velocity attributes when interpolating position, and basically what that's doing is it's looking at the velocity attribute and then like it's moving the geometry in the direction of the velocity attribute. And for whatever reason, I find that it seems to work better if I do it, if I turn that off. It seems like it might run a little bit faster. It's just interpolating the point's position now. I don't know if it makes any difference in this instance, but I decided to go with that way. So now we got this loop. Let's check out what's going on with our camera. So if I look at our camera, we look through our camera here, we go to the end of our loop. Our camera is still tracking. If I turn on, let's go back over here. If I turn on these old markers here, our camera is still tracking the old location of our colliders. It's tracking the trackers. The attractors, rather. So the centroid here, if we click on one of these, you can see it's looking up the attractors for its center position. And we actually want to recenter this centroid onto our retimed colliders. So I'm going to just throw down a null here, and I'm going to put this as the I'm going to just make another label here so that we can reference it. So I'm going to label this retimed colliders, like so. And then what I'll do is let's just I'm going to just turn off the particles for a second and just have the colliders doing their thing. So yeah, clearly the centroid is in the wrong place. I'm just going to hit the D key and make the background dark again just to make it easier to see that null. Yeah, so that null is not following the center anymore. It's looking at these attractors up here. So we want to just repoint it back down here. I'm just going to grab this piece of text for retime colliders. It says retime colliders 1. Just want retime colliders. So I'm going to grab that. I'm going to copy it. And then when I go back up here to my centroid, first thing I'm going to do is I'm going to actually put this on manual mode because Motion Effects is going to start to recook while I'm in the middle of trying to write these new expressions in. So I'm just going to go like this, paste in retimed colliders on this channel. And I'll go to the next one. Same thing. Paste that guy in. Next one. Select attractors again and paste that in. It looks like I accidentally deleted some slashes, so we'll put a slash in here and here. Cool. So now the let's see. Oh, it's I gotta change this back to actual update mode. So let's say turn auto update back on. And it's going to have to think about this for a little bit. You can see down here in the corner that it's sort of, in the lower left-hand corner, that it's sort of thinking about things for a bit. It's got to kind of compute the entire timeline. And since we have quite a large timeline now, it's going to take a little bit for it to sort all that out. So now we've got this nice slow motion, and that centroid is following along nicely. Let's see what our lag target's doing now. If I pull up my Motion Effects view, if it's still not up, I'm just gonna hit this plus icon and bring up Motion Effects view like so. You can see that our Motion Effects view is only going up to 1,000. So it's following the lag pretty good, or the centroid rather pretty good, but it's just not keeping up with it anymore once we get beyond a certain point. So I find that sometimes what I got to do is I got to jump in here and kind of jostle some things loose. So what I'll do is go to the lag target clip 1. Let's go up to the channel, and it says use full animation range. I'm just going to switch it to current frame and then switch it back to full animation range, and it comes back. Not quite sure what the deal is there, but it seems to have fixed the situation, which is cool. So now that we've slowed down the camera, it might not even be necessary to be lagging at this point, but let's just check and make sure our loop is still working properly. So our camera's moving around like so. We get out to around frame 2400, click and play, and it loops back to the beginning seamlessly. Perfect. So that's all working out. Now I could do something fancy like bring this I could retime this node so that everything lines up with frame 1, but I found in a previous take of this tutorial that kind of led to some trouble with the motion effects. It can be a little bit touchy when it comes to this retiming stuff. So just be aware of that. And, you know, ultimately you're probably going to want to do your own camera animation at the end of the day in cinema, but I just thought it was cool to kind of set up this rig that could sort of follow our sim for us and kind of do the work for us, just because proceduralism is cool and fun and satisfying when it works like this. Because basically we've done this entire camera animation with setting, I think we set only 2 keyframes in this entire project, and that was on this blend shape, this one blend shape. So cool. So now I think the next thing I want to do is just let's make a little artistic decision about what we're going to do with our collider. I'm going to bring the particles back on, and I've decided what I want to do with the collider is I just want to shrink the spheres down so that they actually are more like surrounded by these other balls, and just sort of have like a force field around them. So let's just jump back into the collider real quick here. And then we've got a retime colliders. I'm just going to reshape them. So let's just hide other objects for a second here. So I'm looking back at the colliders. Actually, no, I'll ghost other objects so I can see the particles, but I don't know. It looks like they don't look very ghosted to me, but whatever. We'll just go with it for now. So I'm going to go down and throw down a for each connected piece. So this is going to actually just look at you know, each individual sphere, and then I can scale each sphere down by itself. I'm actually going to switch this back to hide other objects. So we've got our 3 spheres here. Just going to throw down a transform. Now with this one in here, if I just uniform scale, it's just going to scale it down to 0 in that axis, and I actually want to scale it about its center. So I'm going to just move the pivot translate to another centroid function, yet another centroid function, centroid of 0th input, so the first input, and then we're going to do dx, and then I'm going to control A, control C, tab, control V, backspace, or left arrow key, Y, and then tab again, and paste, left arrow key, delete, and Z. So we've got our centroids, and we're now scaling each of our spheres about our centroid. So let's do something like 0.5, and then I'll just turn back on our other objects, and you can kind of see how the colliders are playing in there with these. Now we've got these like smaller spheres, and they're sort of pushing particles around. But I like how from this view we actually get to see some of these like back faces of well, I guess like almost the insides of the collider. I don't know, it just for whatever reason, I don't know, I just like it. So cool, we're gonna go with that for this. And another thing I wanted to do before we export is I just want to, you know, address what happens when they intersect. So it looks like in this they really only intersect when they come to the middle, but I just want to clean that up a little bit and have it be, I'll just make a little VDB. So let's convert this or say VDB from polygons, just to give it a little bit of a metaball-like behavior when it gets close. I'm just going to change the voxel size to 0.05, and then we'll do a VDB smooth SDF, and that's going to smooth our volume. It's going to shrink them down a little bit, so maybe I'll come back up here and bump them up to maybe 0.65. Seems good. Yeah, 0.65, just to kind of keep the sizes similar after the smooth. And then let's just go forward to a point where they start to interact with one another, like here. Let's just crank up the smoothing. Let's change the radius a little bit so it's like so, like that. So now they kind of go and they'll collide with one another and so forth. I don't want them quite disappearing like this, so I might actually just bring this resolution down and cut it in half again. A lot of times what I'll do is I'll work in powers of 10 or I'll work in powers of halves, cutting things in half, doubling things, and so forth. So our collider's doing this. It's kind of got this little blobby type behavior when it gets to the middle. Just because and simply the only reason we're doing this is because these moments right here where we get this thing happening, I just don't want that. I'd rather, I mean, this isn't that much better, but I'd rather have this than this. So be it. So I'm going to now convert this back to a polygon. So convert VDB, and we are back into a polygons. And let's just turn on, I'm just going to switch this to smooth shaded to make sure it looks all right. I mean, yeah, that seems pretty good. It's not the highest res thing ever, but it should be fine. If I really wanted to, back here on the smooth ownership, I mean, I might be able to subdivide this, but I don't think I really want to even mess around with that. Yeah, I don't know. I just don't know if it's worth it. Let's see, maybe I could bring this level down 0.1. Now that gets, that's going to be a lot smoother, but it'll take a little bit longer to calculate. Yeah, it's taking a while. I don't really want to deal with that. So I'm going to just bring this radius back up to 0.25, I should say. And there we go. So this is going in generally pretty fast. I could try. Yeah, this is gonna mesh out pretty fast. So what I could do is at this point create a limbic of this to export it. And so at this point we'll start the section where we start talking about how we're gonna export this thing and get it into Cinema. So I'm just gonna throw down a null here and call this the end of the. This is sort of the collider export geo, or final collider geo. I don't know. Final collider geo. I don't know. I have a thing against using the word final. I think that it's bad karma. It just means that you're going to have to revise it at some point just because you're jinxing it. So we're just going to call this we're just going to call this our spheres of influence. Yes, I like that. I don't even know what that means. I just remember hearing that somewhere. Anyways, so spheres of influence. Lame. Anyways, we're gonna take this and then export this as an alembic. Now, because we are coming out of Houdini, and Houdini is about 100th of the size, because Cinema is using centimeters, and Houdini is using meters, we got to scale everything up by 100. So I'm just gonna throw it on a transform and scale all this up by 100. So it's gigantic, which is great. Hit spacebar F. That should frame things up nicely. So this is big. That's good. And then I'm just going to middle mouse click on here and see what kind of attributes you have. It looks like we have a name attribute still. That's probably was created by this connectivity right here. Actually, it doesn't look like it was. It's class. The name was created, I think, by the VDB. Yeah. So we don't need that attribute. It's not going to take up a crazy amount of space because this isn't that high poly, but let's just delete that attribute as you do when you're making alembic files to send to Cinema. So attribute delete, and we're just going to blast away that primitive name attribute. So now when we middle mouse, we just got positions, and that's good. So I can do a ROP alembic output this point and wire this guy in here. and we're going to render the frame range, and we're going to render from 840 to 2400. So let's do, I'm going to delete these channels, and then say we're going to go from 840 to 2400. Cool. And then the Alembic file is going to be hip output ABC. I like to do a similar thing here like I do with my other saves. I'm just going to name this after the file that I used to create it, and I'm going to put it in an ABC exports folder. So I'm going to create ABC export like so, and then call this $hip name.abc. So that will evaluate to our project structure, and then we'll make ABC export less than 07C pop v3 ABC. Cool. I also want to incorporate the operator because I'm going to be exporting another Alembic for the particles in just a second. So let's just do hip name. I'm going to put in backticks here so that I can include another variable along with this, and then say, actually, I'm going to go up here. I'm going to go back here and say $OS. I'm going to put this one in backticks too. Put an underscore between them, and then check to make sure it's evaluating. So middle mouse click on Alembic file, and we get ABC export ROP Alembic 1 underscore lesson 07 pops VO3. It's a little bit verbose, but yeah, we'll just go with it for now. I'm just going to throw down a null right here. I'm actually going to throw down a null and call this spheres out. And then this Alembic I'm going to call spheres out as well. So I'm going to export this and pause the video, and then I will be right back. So I'm going to hit here, save to disk, and you can see that a little progress bar is going to pop up, and it is going to be writing out this Alembic file. So if I go into my file here, there we go. You can see it cranking through all those 1500s of frames. In my project view, I've got the ABC export folder, and our Alembic for the spheres out is being written in there as we speak. So I will be back in a few minutes after this is done writing out to disk. My Alembic kicked out, and it looks like it was about 500 megs. Not bad. Now I'm going to just go over here and let's talk about exporting these particles. So they're obviously really small compared to our frame, so we're going to enlarge them the same way we did the other one. So let's put down a transform again, and we're just going to scale these guys up to let's see, a scale of 100. And am I seeing them? Let's see. I'm just going to frame this up. It's not gathering them from that frame because we're outside of the range of the original cache. So if I go back, there they are. Now if I do this blend shape and retime and transform, hit spacebar F, they're not showing up. The reason being is we kind of covered this in one of the other lessons about exporting in scene scale, is that the particles are all here, but their particle sizes have not been scaled as well. Now this transform node will transform let's go to the geometry spreadsheet. It transforms the actual positions of all the points. So if I go to this retime here, our positions are here, and then they are scaled up. But if I go to view, I'm going to hide all attributes and then say view p scale. P scale is not being scaled. So if I go back to retime, p scale stays the same it stays the same value, and then on transform, p scale is still the same value. Now it will do stuff like scale these. It'll scale these positions and forces and stuff like that. But I need to also scale our p scale by hand. So I'm going to do that by throwing down a point fob. And in here, we're going to just bind. Oops. Bind and bind export our p-scale attribute. So I'm just going to select both of these at the same time and type in p-scale. And then I'm going to scale. I'm going to add a multiply constant. And I'm going to wire p-scale in here and wire the scaled out and write that value to 100. So now when I go up here and highlight the point VOP and the transform, our particles come back. So now small scale and the large scale, it's actually scaling our p-scale up. So now before I actually export this as an alembic, what I want to do, and you can see our p-scale is updated down here. What I want to do is delete a lot of these attributes. I'm going to be bringing in all these attributes if I don't clean things up, and that'll actually create a much larger alembic file than we actually need. The only thing we really need are probably position, and maybe I want to keep color because I'm going to use that to drive a shader, and maybe I'll keep the velocity around just in case we need it, but the rest of this I can just can it. Don't need it. And plus, if we do need it, we can always come back and rewrite out a new alembic file. So I'm going to throw down an attribute delete like we did on the last one, and just wire this thing in here. Will it go? Okay, there we go. Attribute delete, and then point attributes. I'm going to say I want to keep velocity, and I'm going to keep where's p-scale? I want to keep p-scale and color. CD. Good. So now we're actually deleting point attributes. I'm gonna say I actually don't want to delete these. So I can denote that by saying don't delete by putting this caret in front of each one of these. But then I got to go back to the beginning and type in a star. So this is basically what this notation says. It says delete everything, because the star basically is a flag for anything. Delete everything except for velocity, p-scale, and color. So now if I middle mouse click on here, I have 4 point attributes: color, position, p-scale, and velocity. Now I've got these other ones, .object, .path, blah, 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 blah. I don't want any of that stuff. But you can see that our sprites were being stored in an attribute as well. So now we don't see our sprites anymore, which is fine. I'm just going to put in stars for all the rest of these fields so that we can delete all of them as well. So now middle mouse click, and we've got a couple groups left over, but our attributes are looking clean. So I'm just going to throw down a group delete. These are groups that are left over from the solver, from the simulation. So I'm just going to delete all the groups. So now when I middle mouse click over this, I've got, nothing but 100,000 points and 4 pretty basic attributes. So we're in the right scale. Our particles have been scaled. And now we just need to throw down a null. I'm going to call this particles out. What did I call this one out here? It was spheres out. I'm going to call this particles out. And then I'm going to throw down another alembic. And in fact, I'm just going to copy this alembic so that I can keep all the notation or the same file path structure that I used over here. I'm just going to call this one particles out. And just wire that in here. Frame range is the same, and this will automatically update to our particles out file name. So I'm just going to fire this one off, click save to disk, and let that write these bad boys out. And I will be back when this finishes creating that alembic file for us. All right, so that has finished caching out to an alembic file, and it is let's see here. It became about 3 gigs. I could probably have a much smaller file size if I didn't export velocities. And honestly, I don't even really know if velocities will work, but they should work. This is in case I wanted to do like a motion blur type thing at render time. It needs velocity to kind of calculate that. So I just left them in, but because this is slow moving, it might not really be necessary. You could probably get away with just doing something like using RSMB or you know, just the built-in pixel motion blur with After Effects or whatever. So, but at any rate, those have been kicked out now. And then the only other thing I wanted to get was the camera. The camera, we can't really kick that out in the same way as we would wire it into, you know, one of these. So I'm actually going to just export it using the actual export option up here. So under File, Export, Alembic. Then I'm going to choose a file. I'm going to go to the ABC export section again, and then I'm going to just write down $hip name underscore, and then I'll put I'll put it in backticks actually. $hip name, and put another backtick here, and then underscore cam. What is this cam? Cam 1. Sounds good. And then we'll put .abc because we got to do that too. Hit accept. And the export with take, we're just using a current take. Frame range, we're going to set it to be our 840 to 2400. So 840 to 2400 like so. And the export is it's flagged to export everything. I'm going to just select our camera. So accept pattern and export. And I don't know if it does, if it did it already. Let's see. Yeah, it looks like it exported that cam pretty fast. So that's there. So let's now import this stuff into Cinema and see what we can get going on. So I'm just going to switch over to Cinema here. I've got a project I've preset up with some shaders and some lights, and I'm just going to import these Alembic files. So I'll go to Merge. I'm going to go to my ABC export folder, and let's bring in the camera first. So let's open that up. And by default, it's going to scale the camera up by 100. I think that that's going to be something that we want because I actually didn't scale the camera before I exported it. So good to keep in mind. So let's click OK, and our camera is there. Looks like it looks like it's facing the wrong direction, so I might need to rotate everything, which is fine. So I got my camera here. Let's just look inside the camera real quick and see if it's actually, is it animated? Yeah, it looks like it's animated. It starts animating at what was it, 840. So I'm going to set our frame range now. We're going to go from 840 to, I think it was 2400, something like that. So here's our camera doing its motion. That's cool. It looks like it's working out. Like that translated over. So cool. And let's see if I can display. Yeah, cool. So we've got the. Let me just get out of the camera real quick here. So we're out. We've got our camera here. If I look at it, it's got its little animation going on, which is cool. Nice. And then the other thing I want to get is the particles. So let's merge in the particles. So open. And frame rate is 24, but I don't want to scale this one up because I have already scaled it on the Houdini side. So I'm going to put this to a scale of 1, and then I'm leaving all this stuff on: normals, UVs, color maps, and other attributes mainly. And these are particles, and I want to choose to import them as particle geometry this time because because you'll see in a second that we can use this with thinker particles to look up the attributes. So hit OK, and our particles show up right here, which is cool. And then to get our sort of lighting rig setup, it looks like I'm facing the opposite direction. I'm just going to throw everything into a null. So my area light plane, my background rather, and the sky and area light. I'm just gonna throw all the. Let's just create a null, put all these guys in there, grab the null, and give it a 180 up here. Oops, not 1890. Cool. So our particles have come in. Let's just look through our camera again. You've got our particles doing their dance like so. Camera's following them. Nice. And let's do, does it loop? Let's go to the end here, play it through, and it loops back. So cool. Looks like I might need to make my grid a little bit bigger. So I'm just going to take my plane and scale it up just to compensate for the fact that the camera's going to be drifting around and I don't want it to go off screen at all. So let's also bring in our spheres. So let's go up to File, Merge, and merge in the spheres. And that all of these settings are okay as well because we, again, scaled our thing up and we want just whatever the rest of the defaults are good. So open that, and we got our spheres here. So now we've got all this stuff from Houdini hanging out here in Cinema with us. We got our spheres pushing around all these particles. It's looking cool. So, and we got a little bit of metaball action going on like so, and it's great. So let's see what our, let's just render this straight up and see what it looks like. I'm gonna just open up my Redshift render view. So I'm in my render view and just gonna click render and see what we get. Cool, so we get our metaballs and that's about it. We need to get our particles working. So let's stop this for a second. I'm gonna just bring this in here and let's just turn off post effects for right now. What we need to do is get a redshift tag on our particles. So let's throw down a redshift tag, redshift object. And you can see that it sees this alembic object as particles. That's good. The redshift object will detect that it's particles. We can just put down, we want it to look up sphere instances. I'm just going to turn off the collider for right now so we don't see those spheres. And let's just try this again. I think that, let's see, on these particles, I'm going to maybe, yeah, let's just render this and see what happens. Cool. You can see that it has brought in all of our particles. I'm just going to pop out of our render cam and just kind of look at this from a distance. It's brought in all of our particles, but they're all just one color and they're all one size. So we need to get at those attributes. Let's just do that, and we can do that using thinking particles. So I'm just going to stop the IPR, and I'm going to go up to my simulate thinking particles settings. And I can see I've got my export particles group here. It looks like I have a source particles group from another example when I was building this project. I'm just going to ignore that. And we're going to go over here and we want our export particles. So I'm actually going to throw down a, let's throw down a espresso tag onto our particle object here. And I need 3 nodes. I need a ppass. I'll type in pass. So I need ppass, I need a getter. So thinking particles get data, and a setter, p set data. So in the pass, so if I have this pass selected, I want to actually put the export particles group in there. And so I'm going to actually pass those into the get data. And then out of the get data, I can set that stuff. So I'm going to also pass the ppass into the particle over here. And then in the get data, in the output, if you look, we can see we've got our CD, which is our color that we made. And we've got our P scale that we made, which is cool. So I'm going to actually take the color, and we're going to put the color into color on our set data. So when you look in here, you can see like there is a CD vector and there's actually a color attribute, but really we're looking at CD. We're looking for things that look like they came from Houdini. Basically, we know our CD attribute is color from Houdini, so we're going to grab this guy and wire it into just regular old color over here. So that's just a kind of important thing to look out for. Another thing we want is we want P scale. So P scale, we don't want scale. That's just scale. We want P scale. So I'm going to grab P scale, and I believe now there's 2 different size. There's scale and there's size, and I think that we just want to wire this into size. So I'm going to wire P scale out into our size attribute here. So now we should have colors. on our particles. So let's render this again and see if those scales and particles showed up in the way we are hoping they will. I'm not seeing anything yet. And I believe that this is due to the fact that it needs to be reset to 0. So there, I just went back to the first frame of the alembic, and you can see that our particle scale is starting to show up. Not seeing too much on the color front. So what I'm going to try to do is, maybe I can get, just to be sure, I'm just going to put this back to frame 0 here. And I'm going to try and actually go to frame 0 and see if that does anything. Sometimes it will, sometimes it won't. But at any rate, we don't want to use this default shader anyways. We want to use a particle shader. So basically, I just created a redshift material, and it's a mixed material. So I'm just I'm gonna start here. It's at a starting point for us. I apply that, and it's not going to do much because we haven't hooked up our attributes. So let's see if those attributes are working. I'm just going to open up my shader graph, and you can see I've got 2 mixed materials. One of them is this gold shader, so I'm just going to wire that in so we can kind of see what that looks like. So I'm just going to bypass the mixer and go straight to the surface, and we got gold. So we've got gold particles, and we also have this. We've got this material that I will be driving with a ramp. So I want to use this ramp and remap the colors coming from our alembic file. So I'm going to use a user data. So let's type in user. So we've got a color user data info right here. I'm just going to grab that and drop it in here. And then I'm going to actually wire this directly into the surface output. This just sort of helps me visualize what's going on without having to worry about what impact the rest of the shader's having on it. And then so here, in the attribute name on the right hand side here, there is a TP data channels, and we've got our CD vector. So now if I bring that one in, and let's go reset back to 0. Now you can see that we've got these solid colors coming in for our grayscale values, which is great because now I could wire this into our ramp, for example, like so, and wire this out to our surface. And you can see that these colors are taking on the colors of this ramp because it's remapping that grayscale value. So I can actually just bring this and just tie it straight into this redshift material diffuse color channel. And if I wire this guy into the output, now the spheres are shaded and they have those colors. I'm just going to switch back to the other camera here. And you can see, so you can see all these colors. So now we also could create a, now we could also, we could use another, let's go. We could use another, there we go. Sorry, I was having a hard time navigate. We could use another ramp to kind of split some of these colors off and have them be gold instead. So let's grab. What I've done is I've created another ramp here, but I'll just do another one. I've got a note, like I kind of did it like that. I'm just gonna throw down a ramp, search for ramp, and wire this in here. I'm going to get out of this view because it's not like particularly in a good spot. So let's go right here for right now. Bring back up the render view. So now we've got these here. Now if I take this color user data out and wire it into this ramp, we get a general grayscale, which is cool. But now if I were to crush these values together and such, then wire them into this mix material as the layer 1 blend color, and then wire this out to our surface, it will kind of give us a blend between the two. So we're using that grayscale value that originally came through on our points to kind of select different materials for our particles. And I could go here and just really crush this out. I'd say maybe I don't want quite so many gold particles, so I could actually tease them out by bringing this value up like that. And, you know, we get some intermediate silver balls. I'm kind of liking that. In my previous example, I kind of actually had these crushed, so really only gold was showing up, but I kind of like the way it looks when it mixes just a little bit. It adds just a little bit of variety in there. You get some silvery looking balls and whatnot. So that's cool. So this is like a way that you can actually get the color information out of your particles and onto your geo in your render in Cinema 4D. So the other thing that I want to do is maybe I also want to, let's just bring back those colliders. So those are now in the scene. Maybe I'll drop the shader that I have for the spheres on them. See how that's looking. It's just a refractive material. I'm not particularly sure if this frame is doing anything interesting with it, but maybe if we go to a different one, it will look cool. I'm going to go and move back into my camera, and let's check out the camera real quick. It looks like it's, yeah, okay. I was zoomed in way too far. It looked like it wasn't framing it properly, but it looks like it's framing it nicely. Yeah, you can see we got these nice kind of soft refractions here. I just want to see what it looks like with post effects. It's a little bit intense. Maybe I'll desaturate this a little bit. But really, and this bloom is just out of control. It's really easy to let's just go nuts with the bloom, right? Let's bring that down and bring the threshold up, something like that. Cool. So we're able to, you know, kind of get this in here. And you can just kind of mess around with the look from here. You've got everything's moving around, and you're rendering Houdini particles in Cinema. Now, we're only working with about 100,000 particles right now. If it were more particles, it would kind of not work so well. I found that when I get into like the 2 millions of particles, that it starts to fall apart. But because we're using a relatively low number of particles to pull off this sort of an effect, it's looking like it's totally functional as a means of transferring particles. So I hope that you thought that this lesson was cool. It was really sort of taking all the theory that we had learned and really beginning to apply it in a practical sense. Taking a project and all the way through to the point where you should be comfortable. We're in Cinema, and I believe that you know, as soon as you get these assets out of Houdini, you should be comfortable in whatever program you are comfortable using them in. But so that wraps up this lesson, and in the next section, we're going to be looking at rigid body dynamics. So stay tuned for that, and I hope you had a blast. I know I did, and I'll catch you at the next one.